Hey everyone, so we're all online pretty much constantly, right? But if you ever stop to think about how the internet actually works, like for real, today we're going to trace the absolutely wild physical journey that data takes to get from a server somewhere out there all the way to your screen right now.
I mean, just think about this very explainer. The data that makes it up, it started in a data center, probably thousands of miles away from you. So how did it cross oceans and continents to show up on your device almost instantly? Well, the answer is probably not what you're thinking.
The most common idea is that everything is just wireless. Signals getting beamed up to satellites in space and then beamed back down to us. And hey, that seems logical, right? But for almost all of the internet traffic that we use every day, that's actually a really inefficient way of doing things.
Let's just look at the raw numbers here. A satellite is orbiting way up there, like 22,000 miles up. So for a signal to get from Earth to the satellite and back to you, that's a round trip of over 44,000 miles. That journey creates a delay. You've probably heard it called latency, and you can really feel it. It's just not great for streaming or gaming. Fiber optic cables, on the other hand, well, they give us a much more direct and way faster path.
Okay, so here is the big secret. The internet isn't some magical cloud. It's a wire. Well, actually, it's a massive, mind-bogglingly complex network of fiber optic cables that are physically laid on the bottom of the ocean, connecting entire continents. This is the true physical backbone of our digital world.
So let's trace that physical journey for a second. It all begins in a data center, where this explainer is sitting on a super powerful computer called a server. From there, the data zips into these fiber optic cables. Specialized ships literally use a giant plow to dig a trench on the seabed and carefully lay the cable down. That cable eventually hits land and connects all the way to the router in your home or maybe the cell tower down the street.
Okay, so we've got this massive physical highway system. But with billions of devices connected, how does the data for this explainer know to find your specific phone or laptop? How does it know which turns to take? It needs an address, right?
And that is exactly what an IP address is. Every single device hooked up to the internet, your phone, your computer, even the server holding this data, gets its own unique string of numbers. It works just like a shipping address for your house. You put the address on a package, and the postal service knows exactly where to take it. Online, the IP address makes sure the data gets to the right device.
But come on, let's be real. Can you imagine having to remember a long string of numbers for every single website you wanted to visit? It'd be impossible. That's why we have domain names. These nice, simple, memorable names like theexplainer.com that are way easier for our human brains to handle.
So how does the internet connect these simple names that we type in with the complicated IP address that the computers need? Well, that's the job of something called the DNS, or the Domain Name System. And honestly, the best way to think of it is as the internet's giant, constantly updated address book.
Yeah, this quote just nails it. The DNS is basically a huge phone book. You know the person's name, the domain name, but you need their number, the IP address, so you just look it up. It's as simple as that.
So let's walk through it. First, you type a domain name into your browser. Right away, your browser asks a DNS server, hey, what's the IP address for this site? The DNS server finds it and sends it right back. And now, your browser has the correct shipping address, so it can send a direct request for the data to the right server.
All right, so the server gets your request, it's ready to send you the data for this explainer. But it doesn't just send one massive file all at once. Nope, that would be a clunky, terrible way to do it. Instead, it does something way more clever.
And this is where the real magic happens. The server takes the whole file and chops it up into thousands of tiny little pieces called packets. Each tiny packet gets your IP address stamped on it, plus a sequence number, like page 1 of 10,000, page 2, and so on. Then it just releases them into the network. They don't have to travel together. Each packet finds its own fastest route at that exact moment. Then, when they all arrive at your device, your computer uses those little sequence numbers to put them all back together in the perfect order, recreating the original file. It's amazing.
So what if one of those thousands of packets gets lost on the way? Is the whole thing ruined? Not at all. Your device just notices a gap in the numbers. Like, hey, I got packet 4 and packet 6, but where's number 5? And it just sends a quick message back to the server saying, can you resend that one piece? It's an incredibly smart and resilient system.
So how does all this work without turning into complete chaos? It's all managed by a shared set of rules called protocols. You can think of them as the official language and the traffic laws of the internet. They govern everything to make sure all this madness actually works with perfect precision.
And just as a little fun fact, who's in charge of this whole global system of names and addresses? Well, there's a nonprofit organization called ICANN, and it's their job to coordinate everything, making sure there are no duplicate addresses and that the entire system just keeps running smoothly for all of us.
So, the next time you're scrolling or streaming, just take a second to remember that incredible journey. Your data isn't flying through space. It's racing through a vast physical web of cables at the bottom of the ocean, chopped into thousands of pieces that reassemble perfectly on your screen. Which leaves us with one final thought to chew on. What does it really mean that our seamless, wireless, digital lives are literally anchored to the ocean floor by thousands of miles of very real, very physical cable?